In this lesson, we'll focus on the mole concept. The question reads, an aluminum sphere contains 8.55 times 10 to the power of 22 aluminum atoms. What is the radius of the sphere in centimeters? A sphere is a 3D object, and to find the volume of a sphere, we use volume is equal to 4 over 3 pi r cubed. So somehow, if we can find the volume of this aluminum sphere, we can find the radius. Let's get started. We've been given the number of atoms, and we can go from atoms to moles using Avogadro's number. So if I take this number right now and use this relationship, I can find out the number of moles. Here's how. Let's take the number 8.55 times 10 to the power of 22 atoms and multiply it to 1 mole over this number, 6.022 times 10 to the power of 23 atoms. Notice what I did here. Look at this conversion ratio. We know that this many atoms is equal to 1 mole. So we can flip this where the moles are at the top and the atom units at the bottom, or we can put this number at the top and moles at the bottom. I chose this way because atoms will cancel out if you orient this conversion ratio like this. So now all I have to do is take this number and divide it by 6.022 times 10 to the power of 23. 8.55 times 10 to the power of 22 divided by this gives us 0.1419. Now this has 3 significant figures, so everything after this one is insignificant. However, I will continue writing up until this 7, because if I round to 3 significant figures now, I'll be introducing potential rounding errors later on, since there are more calculations to be made. I'll write down 0.14197, and everything after this 1 is insignificant. So this is the amount of moles so far. The next thing that I want to do is use the atomic weight, or what we call the molar mass, to find out the number of grams. The reason why I want the mass, the number of grams, is so I can use the density of aluminum later on after this calculation to find out the volume. So let's start by using this relationship, and I'll multiply this number by 2698 grams over 1 mole. And by orienting it this way, where the moles are at the bottom, the moles will cancel out, leaving us with grams. Using our calculator again, we have 14,197 times this number, 26.98. We should end up with a number that has 3 significant figures, because the amount of significant figures here don't matter since it's an exact number. We get 3.83035. So I'll write down everything up until this 3, even though I know that this 3 is the last significant figure. 3.8303 grams of aluminum. Now I want to convert this number using the density of aluminum. The density of aluminum is given to us right here. And what I will do is multiply this number by 1 centimeter cubed over 2.70 grams. The reason why I'm orienting this way is so that this unit and this unit will cancel out, leaving me with simply centimeters cubed. My final answer should have 3 significant figures. 3.8303 times 1 divided by 270, 1.4186. Everything after this one is insignificant, although I'll continue writing up until the 6, and I'll signify the significance of this 1 with a dot underneath. So I'll write down 14186. The dot is placed right here. Now that I have the volume, I can use the formula that I wrote at the beginning. 1.4186 is equal to 4 over 3 pi r cubed. I'm going to need to use my algebra skills here to solve for this r. The way I can do that is divide both sides by 4 over 3 pi, and this will leave me with r cubed is equal to this thing. I won't find the numerical value of this yet, I don't need to, because my calculator allows me to write it all in at once. And I'll cube root both sides, and my final answer should have 3 significant figures. So let's do this all at once in our calculator. you will click this button, and your index is a 3. We'll write down 1.4186 divided by 4 over 3 pi, or 4 times pi over 3, same thing. We end up with 0.697. Everything after that 7 is insignificant. So our radius is 0.697 centimeters. That's the answer to question number 1. If you want to see the answer to questions 2 and 3, make sure you watch part 2 of this lesson.